Good day, everyone. So for today's discussion, we're going to be having writing systems of linear equation. But this is already the subtopic of solving systems of linear equation by graphing. So this is the first thing that you have to do in order for us to learn how are we going to solve linear equation by graphing. This is how to write the system of linear equation. So first, let us have this exploratory problem. So, Kulas says, I have 10 farm animals consisting of goats and ducks. So, there are 26 animal legs. How many of each kind are there? So, let us identify what will be the equations that we are going to use. So let us x. Let x be the number of goats, be the number of goats, and let y be the number of ducks. Let y be the number of ducks. So since there are 10 animals in all, so there are 10 animals Colas have. So we can have x plus y is equal to 10. So when we added the number of goats and the number of ducks, we can have 10 animals. So this will be our equation number 1. This will be our equation number 1. So since the goat has 4 legs and the ducks has 2 legs, so let us multiply x by 4 and y by 2 and equate their sum to the total number of animal legs, which is 26. So we have 4x plus 2y is equal to 26 because that is the total number of animal legs Colas have. So this will be our equation number 2. Alright, and then after that, so thus, based on the condition, there were two equations formed. So we have x plus y is equal to 10 and we have 4x plus 2y is equal to 26. So for what number of goats x and ducks y's will both equations be true? So let us try to put some values. So let's try to make a table. So we have number of goats, number of ducks, number of animals, and we have number of legs. So let's try to have 5 goats and 5 ducks first. So we have 5 goats, 5 ducks. So the number of animals is 10, yes. But the number of legs is, let's try. So 5 times 4, so that is 20, plus 5 times 2, that is 10. So 20 times 10, that is 30. So definitely that's not correct. So let's have another one. So we have 4 goats. Let's subtract 1. We have 4 goats and we have 6 ducks. So 4 times 4, that is 16, and 2 times 6, that is 12. So again, the number of animals is still 10, but the number of legs that we have is 28. Next one is maybe we can subtract the number of goats again. So we can have 3 goats and we can have 7 ducks. So let's try if this is correct already. So the number of animals still is 10, yes. But let's see if the number of legs are already correct. And that will give us 26. So 3 times 4, that is 12. And 7 times 2, that is 24. So 12 times 4, 10. 12 plus 4, 10 rather. That will give us 26. Therefore, okay, we can see that there are 3 goats and 7 ducks. That will make 10 animals. And they have the total of 26 ducks. So let's go back to the equation that we have formed a while ago by the condition of the problem. So we have x plus y is equal to 10 and we have 4x plus 2y is equal to 26. So these two equations formed uh, equation form a system of linear equation. So these two equations can be solved simultaneously. So let us check if x is equal to 3 and y is equal to 7 satisfy both equations. So x is equal to 3 and y is equal to 7. So we have x plus y is equal to 10. So let's just substitute it. 3 plus 7 is equal to 10. 3 plus 7, that is 10, is equal to 10. Then that is correct to the first equation. So on the second equation, we have 4x plus 2y is equal to 26. So we have 4 times 3 plus 2 times 7 is equal to 26. 4 times 3 is 12 plus 2 times 7, that is 14, is equal to 26. So 12 plus 14, that is 26, is equal to 26. So as we can see, both of the equations are satisfied by the ordered pair 3, 7. Thus, this is the solution to the system of our linear equation. Okay, so take note. So two or more linear equation is considered together form a system of linear equation. So a solution to a system of linear equation in two variables consists of an ordered pair that satisfy the both equations. So take note again that the solution of that linear equation is an ordered pair. So that ordered pair cannot be interchanged with each other. So let us move forward when two linear equations are graphed on the same coordinate plane. So there are three possibilities with regard to their graph. So first, the lines may intersect. So later on, we will see what does that mean. So the first one again is the lines may intersect. The second one is the lines may be parallel. And the third one is the lines may coincide. Okay. So there's a table here. So we have here the possible result and the conclusion. So the lines intersect. So the system of equation has one solution. Take note of that. So if the lines intersect, so there is one solution. So given by the point of intersection, how can we know the solution? That is by means of the point of intersection. So the system is consistent. Take note of that. And the equations are independent. Okay, so those are the things that you must consider uh, to look for or to know and to see if the lines intersect. And the next one is the lines are parallel. So the system of equations has no solution, okay, because the lines never intersect. So the system is inconsistent. Okay. And lastly is the lines are coincident. So the system of equation has many solutions represented by the totality of points on the line. So the system is consistent and dependent. So take note when the lines are coincident, so there are many solutions. Alright, so there are three only possible results when graphing the system of linear equation. First, again, if the line intersect, there is one solution. The lines are parallel, there are no solution. And if the lines are coincident, the lines has the system of linear equation has many solutions. Okay, so again, you may browse in your notes to see if to see the topics or to see the topic about the Cartesian coordinate plane. So you will be aware again on how are we going to graph, okay, because on our next sessions we will be discussing about the graphing of system of the equation that has unique solution, that has no solution, and that has an infinite number of solution. All right, so that's it, everyone. Thank you so much for listening.